Okay. Good afternoon, friends. We meet again today for our second session on mechanics of solids. Before starting my new session, I would just like to brief out what we had studied in our last lecture. In the last lecture, we had studied what are the different types of loads coming on the beams, what are the different types of beams, and how are beams classified depending upon the different types of supports. Now, different types of supports that are basically studied in our syllabus is roller support, hinge support, fixed support. These three supports we had studied in the last lecture. Also, we had studied different types of loads, that is concentrated load, then point load, or we can call it as a concentrated load. Second was uniformly distributed load. Third was gradually varying load, and fourth was a couple moment. Similarly, we had studied different types of beams, that is simply supported beam, overhanging beams, and cantilever beams. Now, we had also studied that when the beam is subjected to different types of loads, then there is an opposite type of action taking place which tries to keep the beam in equilibrium, and that is nothing but the reaction force. So, how to calculate this particular reaction force, that we are going to study in our today's lecture. To start with, what we are going to cover in today's lecture is, first is analysis of the beam, second is derivation to determine the support reaction, and third is the numericals to determine the support reactions. To start with, what do you mean by the term analysis of beams? Now, analysis of beams is basically to determine the unknown forces. Now, what are those unknown forces? So, unknown forces are nothing but the support reactions. Now, how does this support reaction come into action? So, basically the beam is subjected to different types of loads. When it is subjected to different types of loads, as it is in equilibrium, the beam does not fall down but remain in its position, and that is because of the support reactions. So, how to calculate this particular support reactions? That is nothing but analysis of beams. So, to analyze a beam, we have to find out the support reactions using the conditions of equilibrium. Now, these conditions of equilibrium are basically algebraic summation of all the horizontal forces, that should be equal to 0. Second is algebraic summation of all the vertical forces, that is equal to 0, and third is algebraic summation of moments, that is equal to 0. These are the three important conditions of equilibrium through which we can determine the support reaction. Now, when I talk about algebraic summation, that means we have to consider the sign convention. What are these sign conventions? So, to start with, if I talk about sigma h or algebraic summation of horizontal forces, then we know that we have got a positive x axis as well as we have got a negative x axis. So, if the force is moving towards a positive x axis, we consider it to be positive, and if the force is moving towards negative x axis, the sign convention for horizontal summation is considered as negative. Similarly, if we talk about sigma v is equal to 0, that is algebraic summation of all the vertical forces, then if the force is moving in the positive y direction or in the upward direction, we consider as positive. Similarly, if the force is moving in the vertical downward direction, we call it as negative. So, if the force is in the downward direction, we will consider as negative, and in the upward direction, we consider it as to be positive. Now, we come to the third condition, that is sigma moment is equal to 0. If you recall our last lecture, I had discussed that how the moment is produced. We consider one block a rectangular block. If I want to find out the CG of this particular block, the CG of the block can be obtained by intersection of diagonals. Suppose this is the point where we are getting the center of gravity. If a line passes through this particular center of gravity, then that particular line is called as centroidal axis. Now, if the force is acting on this particular axis, then we call that particular force as an axial force. So, if we are applying a force directly on the axis, what will happen? The block will try to move in the direction of application of force. That means we call it as a translatory motion. But suppose if I am applying a force such that the line of action of the force does not coincide with the CG of this action. That means exactly at 90 degree there will be a perpendicular distance. So, this force will try to rotate the body in either a clockwise direction or in an anti-clockwise direction. So, when the force has a tendency to rotate a body, then we call that particular force is trying to produce a rotation, and that is nothing but a moment. Now, when we know that it is a rotation, so rotation are basically of two types, either in the direction of clock hands or in the direction of opposite to the movement of the clock hands. So, there are two types of movements, that is anti-clockwise movement and clockwise movement. When we talk about anti-clockwise movement will be taken or considered as negative, and clockwise movement will be taken as positive. So, if I want to define a clockwise movement, then we can define clockwise movement as the tendency of a force to rotate the body in the direction of movement of clock hands, then that particular movement of the body is called as a clockwise movement. So, this you can see that this is a force and this is a point, or we call it as a pole at which we want to take a moment. So, moment is what? Force into perpendicular distance. Which perpendicular distance? Line of action of the force and the distance at which the point at which the moment is to be taken. So, the rotation is in the clockwise direction, so that is called as a positive movement. Again, if I want to define the direction of the moment is basically taken with the help of right hand thumb rule. So, right hand thumb rule, that is very important, which decides the movement or movement of a force of a body. So, if I take a particular thumb, so my right thumb only I have to take. If the thumb is in the upward direction, that is, it will denote that the force is acting in the upward direction, and the fingers, they will try to show the movement of the body. So, in this particular case, if we see the force is in the downward direction, so the thumb will be in the right hand thumb will be in the downward direction, and my all fingers are showing the direction, which direction? Clockwise direction. So, that particular movement or the moment will be a clockwise movement. So, always whenever we are calculating a moment, the direction of the moment is considered with the help of right hand. So, these are the sign conventions that we have to consider when we are going to find out the support reaction. Now, how to find out this particular support reaction? So, for that we have to derive a formula, and to derive a formula we are going to consider a simply supported beam. So, to start with, we consider first a simply supported beam subjected to two forces W1 and W2. So, W1 and W2 are the two forces which are acting on our simply supported beam. Let the span of the beam, that is equal to L. So, span is nothing but the distance between the two supports. So, if this is the support A and this is the support B, so distance between two supports, that is L. If I assume that the distance of the weight W1 is at a distance of x1 and distance of weight W2 with respect to support A is x2, right. So, now if I want to find out the reactions, so definitely we know where will the reactions get produced. Reactions will only produce at the support. As our beam is a simply supported beam freely resting on two supports, so our supports are A and B. So, we can say that at support A we will have a vertical reaction, that is VA, and at support B will have a vertical reaction, that is VB. So, our aim is to determine VA and VB. To start with, first of all we have to apply our condition of equilibrium. First condition is sigma h is equal to 0. So, sigma h is equal to 0, there is no horizontal force acting on the system. So, this condition is already satisfied. Then we apply our second condition, that is sigma v is equal to 0. Now for sigma v is equal to 0, that is algebraic summation of vertical forces, what we have decided, if the force is moving in the upward direction, we are going to consider it to be positive, and if the force is in the downward direction, we are considering it to be negative. To start with, first is VA. VA is acting in the vertical upward direction, so VA will be taken as positive. Then W1 is acting in the downward direction, we will take it as negative. Similarly, W2 is acting in the downward direction, we will take it as negative, and VB in the positive upward direction will take it as positive. And as the system is in equilibrium, so the net force that should be equal to 0. So we get an equation VA plus VB that is equal to W1 plus W2. This is our equation number 1. This is our equation number 1. Now we have come to our third condition of equilibrium, and the third condition of the equilibrium is sigma moment is equal to 0. If you remember, I have just explained that when we are talking about sigma moment, that is algebraic summation of the moment, that should be equal to 0. When it will be equal to 0? When clockwise moment is equal to anti-clockwise moment. Also, we have to use a right hand thumb rule to determine the direction of the moment. So to start with, whenever we are taking a moment, we have to take a moment at a support. I can take moment either at support A or at support B. So to start with, suppose I take moment at support A. So we will write down over here moment at support A. Moment at support A. To start with, first is our VB force. VB force is acting in the upward direction, and I have to take moment at support A. So for support A, the distance from VB that is equal to L. So perpendicular, as VB is vertical, perpendicular distance will be horizontal. So VB into L, that is the perpendicular distance up to the point A where the moment is to be taken. Now VB is in the upward direction, and my fingers are showing which direction? Anti-clockwise. You can see the direction of the fingers is anti-clockwise. So anti-clockwise moment we are taking it as what? Negative. So VB into L negative. Then we come to the second force, that is W2. Now W2, what is the perpendicular distance from W2 up to point A? So from point A to W2 the perpendicular distance is x2. So W2 into x2. Now this W2 is acting in the downward direction. So when W2 is acting in the downward direction, my fingers are moving in which direction? Clockwise direction, right? So the direction of the moment will be clockwise, and the clockwise moment is taken as positive. Then third is W1. So W1 into what is the perpendicular distance from W1 till point A? It is x1. So W1 into x1, it is also moving in the clockwise direction, positive, and the last is VA. But the line of action of the VA is coinciding with the point A. So there is no horizontal distance, so it will be VA into 0. So this is our algebraic summation of moments. So from this we will get one reaction, that is VB. So VB into L, that is equal to W2 or W1 x1 plus W2 x2. So VB that will be equal to W1 x1 plus W2 x2 upon L. So from this particular equation we are getting the value of one reaction, that is VB. Now this VB value, if I substitute in my equation number 1, I will get the another unknown, that is VA. So this is the equations through which we can find out our unknown support reactions VA and VB. I think this must be clear. This is a very simple step. We have to assume that all our beams are in equilibrium, and when the beams are in equilibrium, then the net force acting on the system should be equal to 0. So we are using all the three equations of equilibrium and finding out the support reactions at A and B. Now to start with, using this particular equation, we are going to find out the support reactions when the beam is subjected to different types of loads. To start with, I will be basically covering all the types of loading, that is a point load, inclined point load or a concentrated load. Then we are going to also cover GVL, UDL, couple moment and bracket loading. So, all these 5 types of loads I am going to cover in today's lecture, and when beam is subjected to such types of load, how to calculate the support reaction, that we are going to study. So, we have got different steps for analyzing the beam. So, the steps that are to be followed to find out the support reactions are, the first step is we have to draw a free body diagram. So, if you remember in the last lecture I had discussed what is a free body diagram. In the last lecture we had discussed what is a free body diagram. If you remember, free body diagram is a diagram in which we are making the body free from all the constraints. Constraints means whether it is fixed in a wall or fixed in a column or lying on a floor, we are making it free from all the constraints, and we are showing what are the different types of forces acting on that particular beam and at what particular angle those forces are acting, and how many unknowns are there on that particular beam. So, that diagram which shows the physical condition of a beam, that is called as a free body diagram. Now, physical condition means what? What are the forces acting, at what angle those forces are acting, and what are the unknowns that are present on that particular beam. So, our first step to analyze a beam is to draw a free body diagram. The second step is, as the beam is in equilibrium, or we are considering that the beam is in equilibrium, we have to consider